2012 linear motion, question 1a. Particle falls from rest from point P when it has fallen a distance of 19.6 meters. A second particle is projected vertically downwards with initial velocity 39.2 meters per second. We have a rest for the first one. The particles collide at distance d from P. Find d. Okay, let's have a look at the first one. We're going to need time here to find the time at which they collide. If we can find the time, we'll be able to find the distance. So the distance that A travels is ut plus a half at squared. So A actually travels a distance of 9. Well, let's get just in terms of t, how far A travels. It starts from rest. It's positive g going down. That's my acceleration, so plus 4.9 t squared. So what we can do now, we can say 4.9 t squared is equal to 19.6. That will tell me when particle B starts to be projected, how many seconds later. 4.9 t squared is 19.6. 4.9 divides into 19.6 4 times. So t is going to be, well, it can't be negative 2, so t is equal to 2. So the time for particle B then is going to be t minus 2. So if we find a formula in terms of t for particle B, we should be able to come up with equating them to be able to find the time at which the particles have traveled the same distance. So we don't have the distance for B, that's what we're going to need to find. But we have the initial velocity of 39.2 plus 4.9, sorry, t minus 2, not t minus 2 plus 4.9 by t minus 2 to be squared. So this is going to give me 39.2 t minus, that's going to give me 78.4. Then we're going to have plus 4.9 by t squared minus 4t plus 4. So I'm going to get 39.2t minus 78.4 plus 4.9 t squared. 4 by 4.9 is 19.6. And again, plus 19.6. So B has caught up with A, so they're going to have traveled the same distance. So the distance for A and the distance for B will need to be the same. So the distance for A at a time t is 4.9 t squared. And the distance for B at time t is what we just worked out here. We can simplify it first, or just bring everything down. Let's we definitely have only got 4.9 t squared. They're going to cancel. So taking in that one, we have 39.2 minus 19.6 is going to give me 19.6 plus 19.6. And then the two numbers I have are minus 78.4 and 19.6. So if I take away 20 now, 0.4, I'm going to get minus 58.8. So I get 19.6t equals 58.8, and that divides in evenly, that's 3 of them. T is equal to 3 seconds. So they collide after 3 seconds, and our easiest equation we can use here is this one. We use both, but 4.9 t squared is 4.9 by 3 squared, which is 9 4.9s, which is 45, minus 0.9, which is 44.1 meters. That's the distance at which they collide from the point P.